Let's continue our work with factoring by looking at some special factorizations. If I have a squared minus 12a plus 36, I notice that the first term is a perfect square and the last term is a perfect square. So I'm going to try as my first guess at factorization that this is the square of the binomial a minus 6. To check, I simply square the first term, that's a squared, square the last term, that's positive 36. Multiply these two together, that's negative 6a, doubled is negative 12a. So remember, the middle term comes from doubling the product of these two terms right here. So a squared minus 12a plus 36, it does in fact factor into the square of a minus 6. How about 49x squared minus 64y squared? I notice that this is a perfect square, this is a perfect square, and this is subtraction. So this is going to factor as the difference of two squares into 7x plus 8y times 7x minus 8y. So the difference of two squares always factors into their sum times their difference, where the product of these first two gives me this term and the product of these last two gives me this term. You want to check and see that no middle term comes out. If I multiply here, 8 times 7 is 56. Out here, 7 times negative 8 is negative 56. That middle term in this multiplication right here would be 0, and that's why we have just the difference of two squares. Let's look at our next problem. I want to use a little factoring by grouping. What I have is x squared minus 6x plus 9 minus y squared. I see I have four terms and no greatest common factor other than 1. Let's try grouping these first three together, because that looks like the quantity x minus 3 squared, then minus y squared. So in fact, this is the perfect square trinomial x minus 3 quantity squared. Now I have the difference of two squares. That's going to factor into their sum, which is the first term plus the second term times their difference, the first term minus the second term. So here's x minus 3 plus y, x minus 3 minus y. So that is factoring this expression right here as the difference of two squares, this square and this square. Here's our next problem, also one that we're going to have to use a little factoring by grouping. X cubed plus 3x squared minus 4x minus 12, no greatest common factor other than 1. Let's group them together two at a time. I can take an x squared from the first two terms. What's left is x plus 3. From the second two terms, let's take a negative 4 by factoring. What's left is x plus 3. Now, this term and this term each have an x plus 3 common. I'll factor it outside. And what's left is x squared from the first term minus 4. And then, since this is the difference of two squares, it factors further, and I get x plus 3 times x plus 2, x minus 2. So that's the complete factorization of this polynomial right here. Now the last problem I want to do is factoring the, what do we have, the sum of two cubes, and we have to do that by using a formula. This has the form of a cubed plus b cubed. Now the factorization of the sum of two cubes is always the same. It's a plus b times the quantity a squared minus ab plus b squared. And you simply have to memorize this formula. So if I look at this expression as having this form to it, it's a cubed plus 2 cubed. So it's going to factor into a plus 2 times a squared minus 2a plus 4. So if I apply this formula, okay, to this expression right here, then I have the factorization of a cubed plus 8. So with the sum and difference of two cubes, you need to memorize that formula.